right. Thank you, everybody who has joined this webinar. Glad you guys make it. Good evening, good morning to the folks who have joined from different locations across the world. We'll be discussing today, one of the fundamental topics that's taking a lot of traction in these days, based on the all sort of discretionary funding across enterprises are taking a lot of hit, but the executives and the senior stakeholders are looking for ways where there are like cost efficiency gains, and QA automation is one such area where there's a real benefit in terms of cost savings, because it kind of changes the whole paradigm of how the automation takes the shape from a manual QA to a zero touch based automation validations. Right, so our topic is like friction to flow, where we'll be talking more about how the velocity has been a key role in the automation setup, and how this has quantified in terms of measurable goals and a business outcome, right? And there will be a sort of a conversation in terms of how some of the best practices could kind of amplify the velocity and increase your test automation coverage. A little background on myself. I lead the QA automation practice at Lab 49. Lab 49, if you guys are not aware, is a boutique consulting firm specializing in financial domain. And we work with all tier 1, tier 2 banks across the world, financial institutions. And QA automation is at the core of our engineering practice, where we help for the engineering initiatives spanning across front to the back end, and covers the overall comprehensive test automation tooling. Apart from this whole role, I look after the global team that's spread across our different offices across the globe, and I coordinate in different engagements, do hands-on coding for multiple projects, and oversee some of our key marquee client relationships. Really jumping into our quality engineering aspects, right? So why QA automation, test automation is so critical in this area of technological landscape, right? There are four key pillars, right? So we have been hearing a lot of terms about shift left testing. We should be doing a continuous integration and continuous testing. There should be comprehensive coverage, not only covering your UI automation, but to your comprehensive UI to backend, and plus some of the non-functional aspects, which are like the critical public-facing websites, which are critical to the business. What are our performance key parameters that helps shape the brand equity, right? So what we have seen essentially, the critical role plays in the early testing. As we involved the testing engineers early in the game, that brings a huge velocity uptick, and huge quality enhancement comes in at the very early stages of your development of the product, right? And implicitly, it increases your collaboration with not only your QA engineers as a team, but with your entire engineering and product leadership, right? And apparently, with your continuous integration, your cost and resource optimization, comes into picture. You see an essential gain in your velocity. You see an essential gain in your quality of deliverables, quality of your product, and that implicitly reduces your cost, right? And apparently increases your time to market. You are able to deliver versions of product to market quickly and rapidly. So as part of our ongoing research, with key clients, we have worked on multiple projects. There have been a few set of patterns that we have seen across the industry, right? And these patterns are primarily towards the vision of test automation that was laid at the start, and where it has gone further. So out of all those patterns, we have handpicked few of these as part of this talk, which are kind of interlinked to each other, right? In my recent conversations with a couple of senior executives, what we have learned is that, look, we already have a test automation in place, but it's always in a catch-up mode. Our QA engineers are running sprint -1, sprint -2, and there's a huge backlog that needs to be filled so that a comprehensive coverage comes into picture. And on top of it, in every sprint, there's an equal amount of hours that goes on in strengthening the automation which is already being developed, right? So there's the uptick in the cost, there's an uptick in the effort, which overall declines your velocity, right? And in order to meet that velocity challenge, the investment on the QA automation has to be doubled down, right? So the other concern, the other pattern that we have seen is like why we need to hire additional engineers every year, whereas our vision of having automation in place was to lower down the cost, right? So the vision was to spend some dollars at this year and recoup these investment as we progress next years, because the automation would eventually come into picture and provide this whole manual reduction, right? And at the second half of the whole discussion, we'll touch upon the framework tooling is one side of the story in terms of having a comprehensive test automation ecosystem, but what are the other set of practices or strategies that could help us, kind of do a shift left much faster, right? What are those other ways that could amplify the overall velocity based on toolings and practices? And at the end, is there a way that I could measure the investment that has been laid, the strategy that has been laid for my automation? What are some of those KPIs or some of the key matrices that I could gather sprint on sprint, month on month to evaluate the progress of the automation, right? So as discussed, the first three topics are like clubbed together as part of the velocity gap, right? At the first half of the velocity gap, the second side of the coin is the practices that are needed to amplify it further. So my 15 years of engineering experience specializing in automation, what I've seen is like, scripts are the core building blocks of any automation, right? So the real essence of automation comes from the underlying scripts that has been created to cover this manual journeys into an automated manner. So what we have seen is, the fundamental reasons that decline this velocity are some of the underlying framework design approach, very limited generalized fixtures. And why these two happens together? Because as an engineer in a globally distributed teams, we tend to come first in solving the problem rather than laying the foundation strong and steady, so that the next set of iteration of code on top of that base, kind of strengthen it in such a manner that the next journey is faster enough, right? So we have seen this limited generalized fixtures, which are nothing in a, with an example are like, in a multi-channel applications like mobile or web, you have these swipe left, swipe right, drag, drop, clicking on buttons, validating those pages, AG grids, and all sort of generalized set of fixtures that are needed to, create those test automation cases quickly, right? So, and that leads to multiple different gherkin steps, right? For same set of user journeys from an X point to Y point, we keep on rewriting those set of codes, new step behavior driven development steps to create those feature files is like keep on bloating, right? We keep on adding new set of codes without even looking for a generalized or a design pattern in a way that it could be reused, clubbed, and stitched together for a faster iteration of creations, right? And the underlying reasons for these maintenance efforts, we as QA engineers have seen a trend, right? In the UI engineering space, the continuous evolvement is in the look and feel of the UI, right? So and that leads to a brittle test automation, because the UI once changes the underlying locators, which are the key blocks for every automation steps, right? So every automation code is embedded using an XPath or a CSS locator for it to action on the UI, right? So those keeps on changing, and that leads to uniformity challenge in the test designs, high maintenance, bloating of the code across the framework, and eventually increases your time in maintaining that suite sprint on sprint. So this is like a repetitive loop that happens in every sprint, where we keep on writing new code, fixing the existing code, writing new XPath, optimizing those XPaths, and that's vicious cycle goes on and lower downs the velocity of the entire deliverables. So what we have seen as an example, we wanted to illustrate this, right, with a real example of how this has declined the overall velocity. And this is one of the ongoing projects. When we started this initiative for one of our client, and the initiative was into their already brownfield sort of a project artifact, we picked up this whole use case there and figured it out as part of our analysis that the globally distributed team, every engineer feels, coding is an art, right? At the end of the day, every engineer feels that, in order to cover this automated test, I have these journeys of steps to be taken. And they keep on writing these separate code blocks, irrespective of the fact that these code blocks, if are to be reused across other modules, can be benefited, right? So in every module, in every test case, we keep on writing these set of new steps. And there is no reusability being baked into it, except the fact that if I want to just reuse this whole step in the same feature or in a subsequent feature, I could just reuse this only step. But the underlying logic has to be reinvented in every new test case, in every new user journey. And that leads to limited reusability. The reusability here, it's only pertaining to that particular set of steps, but not across the board, across the different set of features. And then it's an inconsistent, implementation. So you have two set of steps to click on a button, right? Both of these steps are two separate code blocks that requires an equal time in creation, maintenance, and reusability, right? And that, consider John as an engineer has wrote a different step for app landing click button, right? And Rohit as an engineer has written a different step for its submenu click, right? Both of them are living in a different code step feature, Java files or JavaScript files, and has their own maintenance effort to it, which apparently slows down the onboarding of a new engineer, Mike, who joins our team from a different project. So for him to get familiarized with this whole code base, to be productive for this new project that he has joined, lowers down because he has to understand all the associated bindings of these steps as part of the project, right? That typically slows down in understanding and eventually in adding new tests to it. And of course, at the end, having all these separate blocks of code increases your overall maintenance effort, right? And that amplifies its maintenance cost. So this is one side of story from a test feature file perspective. But the underlying code, which is our basic building blocks, which are XPath and CSS locators, is a very common problem that we have seen across the board, right? And the reason for that, as I mentioned at the start, that the UI engineering as an example, right? The UI automation as an example is brittle because the design or the branding efforts, when happen on a website or happen on a channel, that changes the look and feel. And the underlying XPath or the locators that we as automation engineers are using change, with the change, gets, change the entire flow of these steps and breaks the entire test, right? As an example, let's consider this whole text where a user is looking for 0 as a text on the UI. And tomorrow, if a new component from the UI automation gets added, it will fail the entire automation because there is a hard coding of indices, hard coding of different HTML tags, which will not work when there is a change being pushed by the design or the UI team, right? So this whole inconsistency is a repetitive loop, which I mentioned at the start in terms of maintenance, in terms of scalability of the test suites. So what essentially we have seen as an impact, and this will be, this will be covered as part of a real use case or a case study, which has an underlying business case being evaluated based on the challenges or the patterns, is a delayed product releases, right? Because the catch-up mode will go on where you don't have the scalability of faster test generation, and you are running behind your releases of QA cycle where the QA validation or certification hasn't happened, right? And the team morale would always goes down because they are in this vicious cycle of just fixing their test every sprint. One test, new test added, 2 test fails, fixes are needed to maintain those tests. And then an extra set of operational cost or resources needed to mitigate that challenge of delayed releases, or the lower quality or the scalability. So eventually, the investment that was visioned as a cost efficiency, it increases year on year with the more efforts needed to maintain it. So is there a real example that kind of quantifies these set of challenges that we have seen, right? The rework, the maintenance, the creation effort that goes in every sprint, or the regression effort that takes for one product to go from one sprint to the real production, right? So we have quantified those as part of a real business case for one of our client where there was an existing automation framework in place. However, they were facing the same set of challenges: scalability, maintenance, and high cost of test creations. So how we quantify those and what were the matrices that were captured as part of our scorecard, right? So the rework effort was in a span of 64 hours per sprint. Every sprint, the QA engineering team has to spend 64 hours to work on fixing the failing test or the changes in the test. And then the 300 hours of effort in every sprint was just going on creating the test. So with automation in mind, with the vision of reusability, the whole essence was to lower down this test creation of effort because your new test would be automatically generated as you progress with building your set of existing tests. However, the story was entirely different. With every sprint, the effort was like kind of increasing, right? And with the overall bigger amount of tests that resides in the regression bed, the effort to certify a release or to provide a feedback to the stakeholders was taking 2 days, right? So you would well imagine every year 24 days was just spent on getting a feedback for the product, right? Which is a very high cost, right? So what we essentially did as part of this, we'll talk in the second part, is like our approach of thinking from a different design perspective or creating an automation and how that could help amplify it. But the strategic outcomes that we saw right after implementing that strategy was like the latest and the greatest tooling, the likes of Selenium and Playwright, and the high quality and speed to market. We were able to implement these transformation activities of reusability, adding the generalized fixtures, unique identifiers, which is one of the key matrix that is captured as part of your UI engineering to help facilitate the automation. And then through a self-managing team where the thorough quality assurance has been set as not part of only UI automation, but a comprehensive front to back from functional to non-functional that help to scale this at a wider level, right? So coming to this whole narrative of like how we approach, right? We understand that as an industry, there are design patterns. There are this page object model design pattern, which is quite versatile, has been used across many different, tooling, be it Playwright, be it Selenium, in past, WebDriver, IO, Cypress. All these tools have this whole underlying, base of page object model, right? What we feel is like, that's the base. If we can amplify that with an approach of an action-driven strategy where your actions are the reusable assets, and how we relate this is using a UI thinking, right? So in UI, in the React world, the whole idea is to create these reusable components, and these components are stitched together from one page to another page. This is the same similar strategy that we also feel that to be stitched for the UI automation, where your onus is just to create these reusable test assets or test components, which are underlying Java definitions or JavaScript definitions, and then identify these common actions, right? And these common actions are nothing but your core functions, right? Your core functions like swiping, dragging, drag and drop, injecting a data file, generating your test data, synthetic test data. All these are like the common action that has to be part of your end-to-end test automation. And then the whole onus is on continuous refactoring. We have seen in projects where we have reached to a stage where it is 90 to 95% reusability and 5-10% is the new test development, which is like the new language bindings, Java or JavaScript. It's purely, compatibility of the same set of test suite for your web channel to your mobile channel, be it iOS or Android. So the whole strategy is based on action-driven framework, right? And that comes with the continuous training of not creating new steps, but try to reuse and refactor the existing one that serves the purpose of not creating new tests, but amplifying the velocity. As an example, and this is a very basic example, there's a lot of other things that goes in terms of creating this as a versatile framework, but this is one of the basic example. If you look at on your left is a sample feature file, right, which has a scenario where we click on different buttons, we do some assertions, which is like the key thing or key theme in the UI automation. UI automation is nothing but a bunch of events and actions like value selection, button click, your drag and drop, you're inputting some fields, a form, validation of grids, and so on and so forth, right? So all these are nothing but actions, and those actions, if are embedded with the element repository, which are your page objects, that yields to a library of action-oriented steps. And those steps are just the core components. And you see on your left the scenario of clicking on a button. We have made it in a generalized manner, in a sense that you just inject your key of the unique identifier. It will do the underlying action based on that particular key. You don't have to rewrite a new step to honor a new scenario or create a new feature file. It is just copy and pasting this whole Gherkin BDD syntax and replacing only the key of the repository. And how this amplifier velocity is in twofold. One, this helps provide a baseline of framework. And it could work well with the developer side of the engineers or from the QA side of the engineer. You have a repository of common steps or common artifact where those common artifacts can be picked up, stitched together to create a different scenario, right? So you're not spending time in creating a new set of scenario or new language binding for these user journeys, right? And typically, this is in line with the unique identifier approach, which we were talking earlier, right? So what we feel is that, if as a development team, when dev and QA works together, they can facilitate this automation testing by adding a unique identifiers, which is nothing but a HTML attribute to a field, right? Which is a test ID, let's say. So tomorrow, if your login page gets rebranded, it changes its color, theme, everything. But the underlying attribute to that particular field where your automation test is pointing to remains the same. The chances of maintaining that sort of suite lowers down because the look and feel is a visual testing side of the world. Whereas the functional flow, there is no change in the elements. So your test will stick to its intended work and will be less brittle to failures because you have a hard-coded test ID attached to it, right? And your test will remain the same in terms of its functional flow, right? So in a sense, we feel from a page object model, if we amplify with an action-driven artifact, it becomes an action-oriented library of steps which could be reused not only in one such project, but can amplify to other set of projects. It becomes a horizontal reuse across different fleets of application because in every other projects, these are the core set of actions that are intended in every automation journey, right? It becomes a template of plug and play across different projects. So how we have measured this whole thing, right? So we took in one of the other projects, which was purely a playwright driven a framework that we build on same strategy of action driven thing. So we have seen with the reusability coming into picture, your overall effort in creation of tests lowers down sprint on sprint. Of course, at the very first, there will be high effort of creating these reusable steps or components. But once these assets and components are built, your overall effort goes down every sprint on sprint because you're able to reuse those steps in different modules, in different feature journeys, right? And your overall velocity that starts from, let's say, 1 test case a day goes to a 6 or 7 test case a day, right? And that amplifies the entire flow of test creation and lowers the cost of test creation as well. Whereas without reusability, the effort keeps on increasing because we keep on adding new set of test bindings, new set of code for every user journey to honor for the automation. And that bloats the entire code base, increases your effort in fixing one, writing the other one, and this whole cycle goes on and on, right? So this is one side of velocity uptake strategy, right? Is there any other way that could help to kind of double down it? We have seen in, as the shift left approach is taking a lot of traction, right? Every projects want to shift left, start at the very early stages when the development kicks in for the product, right? Those sort of early involvement in grooming requirement, writing those tests is right. And that's the sort of right practices. However, if we are still having the automation code housed in a separate Git or a source controlled repository, it also reduces or declines the velocity. And the underlying reason is that we have to maintain two separate code repositories, right? We have to maintain two separate CI/CD pipelines that talks as a parent and child. And once the artifact of the main parent builds, that triggers the underline CI/CD for QA to run those tests and returns back the feedback, which is a elongated cycle of feedback, right? And of course, these set of stacks are duplicated effort, right? You will be mocking a couple of services in the same manner which your engineering team is doing. There will be an inconsistent tooling, a lack of interest in collaborating because the set of stack on the QA would be different to the one which is on the engineering and impacts the overall velocity. However, with a common code base, a unified code base, we feel that the whole code base resides in the same engineering artifact where your build resides. That helps you run your test at a commit level rather than building the artifact, deploying, and then executing. You get an early feedback at a commit level by initiating those tests. The other important aspect is, when you have a cohesive code base, right? And that code base is similar to the one which your engineering is using, right? That amplifies the velocity because it's a similar set of stack. Consider an example, right? With playwriting, a lot of traction, as I mentioned at the start. If your engineering UI stack is a React TypeScript based setup and you have a similar playwright TypeScript setup, it becomes easier with this whole action driven strategy for developers to also contribute to your test, right? So you, at the time of creating those features for the product, you are able to write those tests at the same time. So there is no backlog, there is no sprint -1 or sprint -2 for the test automation. You are able to clear or you're able to build your test as soon as your feature is also in development. So you have a cross-stream visibility at that time. You're able to pair together for your feature development as well as your test automation. And there is no bottlenecks, right? The common problems would be resolved at a single instance rather than at two different places. And eventually you are completely shifting left towards the cycle, as soon as possible, right? So what are some of these, positive outcomes that we have seen with the action-driven philosophy and a monorepo strategy? We see it's faster time to market because your cycle of feedback is not like 2 days, right? It's like quick at the commit level. You are able to test your code at every commit, right? It's a parallel set of builds that run for every developers that provides certification of your code, right? And it's an improved quality because you get a feedback, you get your bugs identified early in the cycle, and you don't have a complicated CI/CD pipeline. It's a single CI/CD pipeline for the entire product. Your test, your environments are spin up during the build generation, and you're able to test it at that time. And then eventually, your mocking services, your all sort of reusability across the board comes into picture. You don't have to spend time and effort in building a similar setup for facilitating your QA. You are able to do it in one go for the entire build, right? So that's more or less about how velocity can be upticked with set of best practices in terms of identifier approach, in terms of action-driven frameworks, and in terms of focusing more on reusability, reusable test assets, rather than building, separate BDD driven gherkin outputs, and eventually with the vision of creating this whole framework as a template for next set of horizontal fleet of applications, rather than reinventing a similar heavy lifting boilerplate code for every new project that happens, right? So that's one side of the velocity. And what we have seen with the combination with this whole monorepo strategy, you are able to see a boost in your velocity at initial stage when when your project is 1 to 10 sprints sort of a thing, you see a 2 to 3x of a velocity. And when it is at a peak performance at a mature level to 6 to 7x, where your engineers can also contribute, your dev engineers can also contribute to the test automation. And that's the end sort of a goal for every tech head, to see, how the collaboration can help in reducing the overall testing costs, and then, sort of amplify the overall STLC cycle as well. So the next part is like, you have all your, framework, tooling, best practices in place, right? So is there a way that we could measure our automation ecosystem? What are some of those KPIs which, we as an engineering managers or a tech head or senior executive can, kind of see sprint on sprint to see how it is progressing? What are their gap? What are some of those gaps in the areas to optimize? And how well this quantifies into quality and cost efficiencies, right? So there are a bunch of KPIs. So we have picked, a couple of them as part of this discussion, and especially focusing on three main aspects, which is automation test coverage. That helps us understand what are our effort bifurcations in automation versus manual, right? So that covers the overall automation coverage for the entire app. Second most important is the automation script effectiveness. So there's no point we create these scripts, create these automation tests, but that doesn't bring any value in terms of defect detection, right? So that's one important aspect of creating these automation scripts, but that should yield into finding number of defects, finding those right defects, edge cases as part of the automation run. And the third important aspect is in sprint automation. How many test cases we are able to cover as part of in sprint versus what are left for backlog, right? All these KPIs help us to track the ongoing performance of our automation in sprint on a monthly basis, right? And we have did this exercise for an ongoing project, and this whole data is realistically from those last 15 sprints, where we are able to gauge, the percentage of automatable test cases, which could be, which could vary on sprint. There would be some sprints which will be more of an infra related, or a tech implementation doesn't have an appetite or an ROI for your automated test, which would increase as you mature the product. Then to the automation coverage, where you will see a drastic uplift in the coverage. It could, be lacking behind during the initial sprints, but catch up once you have this whole set of artifacts baked in, your reusable components, another sort of stuff that could help you, yield the entire automation velocity to the overall percentage progress. The automation test could be 400 or 500. There is no point, that returns 50% pass rate, which doesn't add much value, right? So your overall percentage progress may vary up and down, but to a limit of delta of 2 to 3%, but overall should stay strong in order to yield those automated gains, right? So overall, these matrices on a sprint on sprint basis does provide you the entire traceability of your automation suite, and that traceability connects back to your requirements, that helps you understand the overall coverage of the areas of the product as well. And then it talks about the next set of your velocity gains in order to understand the next year, sort of a team resource requirement, because if the velocity has been an uptick, you have double the agility to either pursue or pivot towards feature development, or to quantify towards other set of priorities. And then the automation progress, which tells you how much effort is still needed to cover the remaining set of backlog, or the remaining set of the areas which are not yet automated, or some specific areas which are like totally manually oriented, and how to mitigate those areas with the automation progress as we move forward, right? So all in all, two important aspects which we have been very proactively working across our enterprise clients is a right set of tooling, a right set of best practices in yielding the overall gains in velocity, and the set of dashboard and matrices that covers the health of the automation ecosystem in different client projects. So that's pretty much from my side. We are right on time, but I'm happy to take any questions. Mike, do we have any questions so far?
I'm not seeing any, Rohit. I did unmute everyone that is here, so they're free to ask away.
Okay. All right. In case folks, you have this questions at the later stage, happy to receive an email and respond back over emails as well. I believe this whole session was helpful. This whole topic was helpful in understanding the overall landscape of changing technology, practices, tooling across QA automation. Happy to take any questions at a later stage as well. That's all for today. Thank you for joining.